Welcome back. The objectives of this video is to solve quadratic type exponential equations and quadratic type logarithmic equations. We'll also verify our answers graphically using our graphing utility. The other thing we'll see here is the concept of U substitution to help us factor and solve what would be quadratic type equations. So let's take a look at example 9. We have e to the 2x minus 3e to the x minus 4 equals 0. Well, this is factorable. We'll go ahead and use U substitution here. And as a rule of thumb, we're going to replace that. Usually the linear term is what we're going to use to do our U substitution. So we'll let e to the x equal u. So u is going to replace e to the x. So we have e to the x is going to replace e to the 2x. So we end up with u squared. I think I said e, I meant u is going to replace e to the x minus 3u minus 4 equals 0. So this is easily factorable. Keep that equal to 0. Factors of negative 4 that add up to negative 3. So factors would be 4 and 1. So minus 4 plus 1. So solving, we get u equals 4 and u equals 1. So now u is e to the x. So we have e to the x equals 4 and e to the x equals 1. Now we have to solve both of these. E to the x equals negative 1. So we'll solve both of these. This one is extraneous. We're not going to get e to the x equal to negative 1. So we're going to work with e to the x equals 4. We'll natural log both sides. So we get x natural log of e equals the natural log of 4. The natural log of e is 1. So we get x equals the natural log of 4. So that's our exact answer. And we can put this into our calculator and get x approximately equals 1.386. We'll get that for a calculator, and that's our approximate answer. Now, if we did want to solve this or verify this graphically, all we would have to do is put this into our graphing calculator and find where that crosses the x-axis. So it should cross somewhere between 1 and 2. And that graph actually looks something like this and comes up like that. And we're just finding the x-intercepts here. So we'll see that that x-intercept is 1.386-ish and 0. So we would use the isect command and just find the intersection there. Or find the zeros, actually. We could do the zeros on our graphing calculator and do that. In example 10, a little bit more complicated. We have a fraction here in example 10. So what we'll do is we'll multiply both sides by 2 to get rid of that fraction. And that would give us e to the x minus e to the negative x equals 16. I'm going to go ahead and subtract 16 from both sides and get e to the x minus e to the negative x minus 16 equals 0. And what I can do here, this is a little different. We're going to multiply both sides by e to the x, which then gives us e to the 2x minus e to the 0 minus 16 e to the x equals 0. Well, e to the 0 is 1, so I'm going to rearrange my terms and get e to the 2x minus 16 e to the x minus 1 equals 0. At this point, we will let u equal e to the x, so we'll do our u substitution again. So we get u squared minus 16u minus 1 equals 0. Now we want to try and factor that, but we can't, so we're going to have to do the quadratic formula, and we'll put our values into the quadratic formula. So putting in everything into the quadratic formula, I get the opposite of b plus or minus b squared, or 16 squared, minus 4 times a, which is 1, times c, which is negative 1. Watch your signs here. This is where high school students make a lot of mistakes, is simplifying under the radical here. And once we do that, then we get u equals 16 plus or minus the square root of 260 over 2. Well, 65 times 4 is 260, so the square root of 4 is 2, so that 2 can come out, leaving me the square root of 65. I'm going to factor out the 2, so my 2 will cancel, and I'll get u equals 8 plus or minus the square root of 65. Now, we can't have u, or e to the x, can't be negative, and the square root of 65 is just a touch bigger than 8. So the negative one here isn't going to work. So our only option then will be to say e to the x equals 8 plus the square root of 65. So 8 plus 8 is almost 16. And then we need to solve this for x, and we'll go ahead and do that by natural logging both sides. So I'll take the natural log of both sides. And I need a second column here. So we get x natural log of e equals the natural log of 8 plus the square root of 65. So x equals the natural log of 8 plus the square root of 65. I'm going to keep that in parentheses there. And that's my exact answer. Now we can go ahead and put that in our calculator, and we'll get the approximate value of 2.776. And then we want to verify this using our graphing calculator. So let's take a look at our graphing calculator and see how that would work. So I'll go ahead and pull up my graphing calculator, and I'm going to put both of those equations into my graphing calculator. I'm going to put e to the x minus e to the negative x over 2, and I'm going to put y equals 8. So both of these guys are going to end up in my graphing calculator. So this might be y1, and y equals 8 might be y2. So I'm going to put those both in. I'm going to graph and find the intersection. So here they are. I've got my plots off. I've got that entered in my calculator. I'm going to just graph these in the standard window. So I'm going to do zoom standard and graph, and I've got a nice picture of those two graphs, and then I can find the intersection by second calc. Intersect, first curve, second curve, guess, 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 and sure enough I get 2.776 for x and a y value of 8, and so I've confirmed that graphically. In example 11, I have the natural log of 3x minus 2 plus the natural log of x minus 1 equals 2 natural log of x. So I have all natural logs. I have natural logs on both sides, and I can apply my properties of exponents here. I have addition, so I'm able to multiply 3x minus 2 and x minus 1. And when I do that, I end up with the natural log of
We're applying properties
3x minus 2
here, not exponents.
times x minus 1. I'll multiply that in just a minute. Equals, and I'm going to apply my power rule here and take that 2 and undo that and make that the natural log of x squared. I'll do that correctly for you guys. There we go. So now I know x squared is going to equal 3x minus 2 times x minus 1. I've got the natural log on both sides. The answer on the left has to equal the answer on the right. So foiling 3x minus 2 times x minus 1 and dropping my natural log, I get 3x squared minus 5x plus 2 equals x squared. Subtracting x squared from both sides, I get 2x squared minus 5x plus 2 equals 0. See, I'm working down the page, my equal sign, and now I'm going to go ahead and factor. So the only factors of 2x squared, if it's factorable, would be 2x and x. It's still equal to 0. And now I know any number I put here, I'm either going to put 1 or 2 here, but it's going to be doubled. So I'm going to try 2. 2 is good because 2 times 2 is 4. I need to get to negative 5. So 1, and they are both negative. I FOIL back. I get what I want. This is correct. Then I solve each of these for x. So in this one I get x equals 1/2. This one I get x equals 2. Now they're both positive, but do they both work? If I go back to my original equation and I put x in, if I do the natural log of 3 times 1/2 minus 2, this is going to be a negative value. So x equals 1/2 is extraneous, and we eliminate that. So x is going to equal 2, and I confirm that that works. In fact, x equals 1/2 here also gives us negative as well. So a couple places that's not going to work. In example 12, now I only have logarithms on one side of my equation. So let's see what that's going to look like and what we're going to have to do here. But I have addition, so I'm going to apply my properties of exponents, and I'm going to get log base 3 of x times x minus 8 equals 2. Log base 3 of x squared minus 8x equals 2. And since I have logarithms on one side, I'm just going to change forms. So I'm going to convert to exponential form. So my exponent on 3 is 2. So x squared minus 8x equals 3 to the second, or 9. So I subtract 9 from both sides. X squared minus 8x minus 9 equals 0. And I'm going to go ahead and factor. I need factors of negative 9 that add up to negative 8. Negative 9 and positive 1. So x equals negative 1 and x equals 9. X equals negative 1 is extraneous because it creates a negative result up there. So that guy's out, and we get x equals 9. So we have in this video we have solved both logarithmic and exponential type equations, exponential quadratic type equations, and you'll get some more practice with this when I see you in class.